Hello everyone, hope you are all doing great. Today I'm going to talk about new topic, is types of random variables. So let me welcome to Statistics Helpline, and I'm Lakshmi here. If you have not watched my previous video that's about random variables, the link is given as a first link in the description. So without further delay, let me take you towards today's topic, that is types of random variables. So, how many types of random variables are there? It's very simple. There are only two types of random variables. The first one is the discrete random variable and the second one is the continuous random variable. So, today I'm going to talk about the discrete random variable. What is discrete random variable? Discrete random variable has finite or countable number of possible outcomes, and I'll tell you a very simple example, that is, you can count the number of people born in the month of September 2019, isn't it? That's how we describe about the discrete random variable. Now, what is a continuous random variable? Continuous random variable has infinite number of possible outcomes. So they are not finite, they are infinite. So what would be the example in this case? If you take the average age of people born in the September 2019, that is infinite possible value. So that's how we discuss about the continuous random variable with a simple example. But before we go ahead and we talk about the discrete random variable and the probability distribution, that's what we are going to sync them together, right? I would like to discuss there are two possible conditions that a probability distribution should meet. Before I talk about the probability distribution, I would like to emerge towards these two conditions. So what is the first condition? The first condition is the f of x should be non-negative for all the random variables that we take. So what is the second condition? The sum of all the probabilities must be 1 for the probability distribution. So these are the two conditions that should meet to make up a probability distribution, which we have to verify all the time. So now let me take you towards a simple example to make you to understand what this probability distribution in the case of the discrete random variable is. So as I explained with a simple example, we need to consider the finite possible outcomes, isn't it? So let me explain it with a simple example. You all know about a fate coin, right? So what are the two possible outcomes of a fate coin? The two possible outcomes of a fate coin are the head and the tail. So I'm going to take two fate coins now. So two fate coins will be tossed simultaneously. You know, if you toss one coin, you will get either a head or a tail. So if I'm going to take two fate coins, I will have four possible outcomes. So what are the four possible outcomes here? Both of them can be heads, that is HH. Both of them can be tails, that is TT. And one head and one tail, which is HT, and one tail and one head, which is TH. So that's how the sample space is made up. But our intention is not to do the sample space here. Our intention is to make up the random variables. So what is the random variable here? I'm going to assume the random variable x as the number of possible heads. So I'm going to consider x as the number of possible heads here. Okay, how will I make the numericals making this experiment? I'll tell you, it's very simple. It's like a playing game. So I'm going to toss both the coins now. Okay, I got two tails here. So my intention is to get the number of heads, right? If I get two tails, what would be the number of heads here? That is 0. So I'm going to assign x equals to 0 when both are tails. Okay? So now I'm going to get one head and one tail, or one tail and one head, vice versa. So in this case, x is equals to 1. Why x equals to 1? I will have one head, right? So I'm going to have x equals to 1. Now I'm going to toss it again. and I got both the heads. So when I have both the heads, I can have x equals to 2. So here all the values that all the possible outcomes that I have assigned for tossing both the coins are countable. That is, x is going to take 0 when both are tails, x is going to take 1 when there is one head, and x is going to take 2 when there are 2 heads. That's it. So I have my random variables, my random variable x with all the values ready. So what is the next task here? Our intention is to make up the probability distribution. So I would like to recall once again the simple definition of the probability here. So what's the definition of a probability of an event? It's nothing but it's the ratio between the favorable cases divided with the total number of events, or the exhaustive number of events. So here, when you toss a coin, it's very simple. Like if you would like to find, it's an yes or no question. Either it can be an yes or it can be a no. If you wanted to know if the baby is a boy or a girl, either it can be a boy or it can be a girl. In the same way, if you toss a coin, it can be a head or it can be a tail. So favorable case would be 1 and the total number of cases would be 2. So now, when I'm going to talk about both the experiments, both the coins, that is, I'm going to toss both the coins and take the first attempt, I had both tails. That is, I'm going to talk about x equals to 0. So how do I find probability of x equals to 0? It is very simple, as I told you, that if you toss one coin, if you get one tail, that is 1 by 2. And another one is also tail here, right? So 1 by 2. So I multiply them. 1 by 2 times 1 by 2, which is 1 by 4. That is 0.25. That's it. So now my intention is to find the probability when x equals to 1. So when x equals to 1, probability of x equals to 1. That is one head, right? It's simple, 1 by 2. And now that's where we switch to the third one. That is x equals to 2. That's both are heads. So again it's 1 by 2 times 1 by 2, which is 0.25. So what am I going to check here now? I have already checked the first condition, and you also have got to know. That is, all f of x values are non-negative now, right? So now my intention is to check the second condition. That is, if sum of all these probabilities, that is, probability of x equals to 0 plus probability of x equals to 1 plus probability of x equals to 2. How much is this? That's 0.25 plus 0.5 plus 0.25, which is 1. Wow! We got some of the probabilities as 1. Super it is. So we met both the conditions, right? That's beautiful. There's a beauty here, you know. So how do we connect it to the data science? It's very simple. Whenever you are going to talk about the data and you are going to make up many trials which are real in stream, or you are going to make a theoretical probability for the data set you have, and data science could consider all these types of random variables. It could be discrete or it could be continuous, depends upon the data science or the data that you are going to work with. So it is very much aligned with the data science too. There's the beauty of the discrete random variable. So I think you understood now how I made tossing of 2 coins into the topic of discrete probability distribution. That's how we met both the conditions and we understood what discrete probability distribution is. I think you really enjoyed playing with me with tossing 2 coins, right? Wow, that's simple. Thank you guys. Thanks for watching the video. And I really enjoy talking to you with these simple examples always. And I will bring back the second type of random variable, that is continuous random variable, in the next video soon. Thank you guys. Thanks for watching my video. If you really like the video, don't forget to give a thumbs up. And if you are watching my video for the first time, please do click on the bell icon and subscribe. And please follow me in the social media. And all the links are given below in the description. And if you have not watched my previous video, don't forget to watch it. It's the first link given in description. Thank you so much. Don't forget to stay tuned with me to enjoy with another simple example to go ahead and enjoy the continuous random variable soon. Thank you. Have a great day.